Okay guys, this is going to be me working all the problems from the Go Formative Thursday night, just in case you need some extra review or clarification before the test on Friday. Number one is an absolute value equation. It's set equal to 8. So we're going to work it the first way, x equals positive 8, or the alternate version, x equals negative 8, because absolute value means distance from 0. It could be 8 units to the right or 8 units to the left. Since there's no other work to do in each individual equation, I already have the answers. It is an equation, so it needs to be listed in braces, or sometimes we call them squiggly brackets, but they are listed from least to greatest. There's our answer. Number two, absolute value equation again. Absolute value is isolated. It's already by itself on the left side. No extra work to do. It's set equal to a positive number, so I need to try both versions. X minus 2 is equal to a positive 6, and then x minus 2 is equal to a negative 6. Work both equations by adding 2 to both sides. And we are left with x equals 8 and x equals negative 4. Those are our answers, and we list them least to greatest. The third question here is absolute value equation, but this time it's set equal to 0. It's impossible for me to set it to 0 and negative 0 because there's no such thing. That means there's only one possible answer to this absolute value equation, and it's the value that makes it equal to 0. So x plus 1 equals 0 is going to help me find out what that would be. If I minus 1 from both sides, I find out the value of x is negative 1. I still have to make sure I list it properly in braces. So that would be the answer to number 3. Number 4, absolute value equation. The absolute value expression is already isolated on the left side, but it is set equal to a negative number. It's impossible for me to ever plug in a value in this absolute value expression, work it out, and come out with an answer that is still negative. That is going to be no solution. Number 5 here, it is set equal to a positive number. Absolute value expression is already isolated, so no extra work. We're going to work it both ways, saying it's 10 units to the right and 10 units to the left. So 3x plus 2 equals 10, and 3x plus 2 equals negative 10. So I will minus 2 from both sides. Left with 3x equals 8 and 3x equals negative 12. So then I divide both sides by 3, and I'm given x equals 8 thirds and x equals negative 4. So I list them in order from least to greatest in braces. So I'd have negative 4, 8 thirds. Okay, our next question, the absolute value is not isolated yet. I have to get everything else away from the absolute value expression before I can make any judgments about where this equation is going to go. So I need to get rid of this plus 4 on both sides, so I'm going to minus 4 from both sides, and that leaves me with the absolute value of 2x plus 5 is equal to 3 minus 4 will leave me with negative 1. So now I can make a judgment. I have absolute value expression equal to a negative number, so it's going to be no solution. The next one, we also have to make some moves before we can make a judgment call. I've got a 2 being multiplied by the 4x minus 1 in absolute value. I can never, ever, ever distribute a number that's not inside the absolute value into the absolute value. These are not parentheses, these are absolute value. They mean something totally different. So since 2 is being multiplied by this entire thing, I've got to get rid of it by dividing both sides by 2. And we're left with the absolute value of 4x minus 1 is equal to 3. So now I can make a judgment based on what's on the right side. I'm going to set it equal to the positive version. And also, if it had been 3 units the opposite direction, would be negative 3. So I'm going to start solving each one by adding 1 to both sides. So it leaves me with 4x equals 4 on this one, and 4x equals, that will leave us with a negative 2. Finish dividing by 4 on both equations. We're left with x is equal to 1 and x is equal to negative 2/4, which is just a negative 1/2. So write them in order from least to greatest. I will have negative 1/2 or negative 0.5. Either one is fine. And then a positive 1. Our next one, we've got several things to move away. I cannot get rid of this 1/4 yet until I move over that positive 1. I mentioned earlier it's nice to kind of think of the absolute value expression as if it was just a variable and we were trying to get a loan. So for the purpose of isolating the absolute value expression, I would work it as I would if I were just trying to isolate a variable. I would minus the 1 from both sides, and then I would multiply by 4 to get rid of the 1/4, and then I would have my variable alone. Well, I do the same thing with an absolute value equation to isolate the absolute value expression first. So we would minus 1 from both sides, and that would leave us with a 1. And then to get rid of the 1/4, we would multiply by 4. So 1 times 4 on the other side would leave us with the absolute value of 2x minus 6 is equal to 4. Now we can pause and make a judgment call. Over to the right, it's equal to a positive number, so I've got to solve it both ways. Oh, sorry, you need to drop the absolute value symbol. So 2x minus 6 equals 4, and 2x minus 6 equals negative 4. So when I add 6 to both sides, you're left with 2x equals 10, and 2x equals 2. So when we divide by 2, on both sides, we get x equals 5 and x equals 1, so we list them from least to greatest, 1, 5. The next one, same thing here. I need to add 6 to both sides, so that will leave me with negative 3 still out there, but now it's going to be equal to 9. And now I've got to get rid of the negative 3 being multiplied, so I'm going to divide both sides by negative 3. And when I do that, I'm left with the absolute value of x minus 1 is equal to 9 divided by negative 3, leaves us with negative 3. Now the absolute value expressions alone, we can judge what to do next. It is equal to a negative number, so it will be no solution because that is impossible. This next equation, we need to minus 2 from both sides to isolate the absolute value expression. We're left with x minus 7 equals 0. So just like towards the beginning, if we have it equal to 0, an equation equal to 0, the only thing that is the answer is the one number that will make this equal to 0. So we've got x minus 7 equals 0. When we add 7 to both sides, x is equal to 7. So the only answer to this one was a positive 7. I will list it in braces because this is the answer to an equation. The last two equations were where we had absolute values on both sides, so we said we're going to treat the left side as if it was the normal absolute value, and the right side we would treat as if it was just a positive number over there. So we're really looking at 3x plus 2 equals the positive version of x minus 6, and then 3x, let me clean that up a little bit, and then 3x plus 2 equals the negative version of x minus 6. On this top one, there's not much to do other than work it. On the bottom, we have to be sure that we distribute this negative to both terms in the parentheses. So on this first one, I'm going to start by getting the x's together. I will add x to both sides. I have 4x plus 2 equals negative 6, minus 2 from both sides. 4x is equal to negative 8. And so when we divide by 4, our first answer is x equals negative 2. On the second version, after I distribute the negative, it's going to change what's on the right side. Get the x's together. I'm going to made a silly mistake. Let me go back. On that first one, I should have minus x from both sides. So we are not perfect. I make mistakes too. At least I caught it. So I would minus x from both sides. I'd be left with 2x plus 2 equals negative 6. Then I would minus 2 from both sides. Be left with 2x equals negative 8. And then when I divide by 2 on both sides, I'm left with x is equal to negative 4. Negative 8 divided by positive 2 gave me the negative 4. Now I can properly work the second version. Once I distributed that negative, I got negative x plus 6. And this time, because x is negative, I will add it to both sides. I'll have 4x plus 2 equals positive 6 minus 2 from both sides. I'm left with 4x equals 4. And when I divide both sides by 4, I'm left with x equals 1. So the answer for my first one comes out to be from least to greatest, negative 4, comma 1. Now for the second one, we've got to do the same thing. We're going to set it to the positive version of what's on the right and then set it to the negative version of what's on the right. We've got x minus 4 equals 4 minus x, and then we've got x minus 4 equals negative 4 minus x. So on this one, we're going to add x to both sides to get our common terms together using inverse operations. Got 2x minus 4 equals 4. Add 4 to both sides. 2x equals 8. And when we divide both sides by 2, the first answer we get is x equals 4. On this side, when we distribute the negative, we get x minus 4 is equal to negative 4 plus x. When we try to get the x's together, if I minus x from one side and I do the same to the other, I'm left with no x's. All I'm left with is negative 4 equals negative 4. Well, even though one of our answers was just a positive 4, the other answer is infinite solutions. Because this answers infinite solutions, that automatically includes this positive 4. So it's like this one trumps this one. So therefore, the end result, the final answer to this one should have been infinite solutions. Okay. So now we get into the inequalities. So our first rule is that the absolute value of x is less than or equal to a positive 2. The absolute value expression is alone, so I can make a judgment call on the less than or equal to a positive number. Your notes should tell you to proceed in solving, and you will solve for the original version, and then you will also solve for flipping the sign and changing the number. So there's no other work to do here because I already have x alone in both of them. I just need to figure out how to properly write my answer. If I were to graph this, I would have at negative 2, x is greater than or equal to. And then if I had at positive 2, I would have x's less than or equal to positive 2. So it looks like this is an and statement. And you should have known that from my little statement that I had you guys memorize. The Go LA, if it was originally a greater than, it was an or. If it was originally less than or equal to, was an and. So things turned out okay. Now I need to make sure I know how to write that in interval notation. So I'm reading it from left to right, finding where my answers lie. It starts at negative 2 and goes to positive 2. Negative 2 is included, it's filled in, so it gets a square bracket, and 2 is also included, so it gets a square bracket. So that would be the way the answer should have been typed in. The next question, it's the absolute value is isolated, it's greater than, and there's a positive number over here, so I can proceed in solving it. So we're going to do the first version, x plus 3 is greater than 4, and we're going to do x plus 3 is less than negative 4. Based on this little Go LA thing, this says it's greater than, so we know this should be an or statement. If I were to work it out and graph it and it did not do what it was supposed to do, then we knew that that was a special case. So we're going to go ahead and continue solving. If I minus 3 on both sides, I get x is greater than 1. If I minus 3 on both sides over here, I get x is less than negative 7. So if I were to put those on a number line at negative 7, it's open circle less than, positive 1, open circle greater than. This is what an or is supposed to look like. Putting it on the number line helps me remember how to write it in interval notation properly because I read it from left to right only where my answers are occurring. When I start reading it over on the left, I start with this arrow going negative forever, so that's negative infinity. It stops at -7, which is not included, so it gets a parentheses, or they start again at a +1 that's not included, so it gets a parentheses, and continue to go to positive infinity. You could have said or you could have put that U for union in between them, and it would have meant the same thing. So the next one, the absolute value is isolated. It's less than a negative number. If you would consult your notes, you would see that that's impossible because the only results that are less than this negative number is more negative numbers. And just like with the equation, we can't have anything in the absolute value as an end result come out to be a negative number. Therefore, this one should have just been no solution. Our next one, we've got a little cleaning up to do. I still have another number or other terms on the left side aside from the absolute value expression. So I need to get rid of the 3 being multiplied by dividing it on both sides. Left with the absolute value of 2x minus 4 is greater than or equal to -9 divided by +3 is a -3. So I can pause here now that I have isolated the absolute value expression. Looking over to the right side, I have a negative number. It says it's greater than or equal to that negative number. So we know from our notes, or even just from reasoning, we know that it can't be equal to this negative number. So that's not the part of the answer that's going to make the final decision. It's going to be about this part where it says it's greater than. Well, positive numbers are greater than -3. So anything I plug in here and work out is going to be greater than -3. So this is going to be infinite solutions or all real numbers. Either one is acceptable. The very next one, several terms to move away from the absolute value expression before we can make a judgment. So I first need to move the 6 over by minusing 6 from both sides. That will leave us with 0. Then we need to get rid of the 2 out front by dividing, and then 0 over 2 is still going to be 0. So we've got the absolute value of x minus 9 is greater than 0. Well, everything we plug in here will be greater than 0, but there might be one possible instance where we plug something in and it equals 0. And because the symbol here does not allow us to have an answer that's equal to 0 because there's not an equal to here, it just says greater than, we got to figure out what's the one number that if we put in here would make it equal to 0, because that's the one thing it cannot be. So we're going to find out by setting it equal to 0 and saying what's the one number that will equal 0, because that's the number it cannot be. So if we add 9 to both sides, x cannot be 9. That's the only number in existence it cannot be. It can be 9.00001 or anything the other direction, but it cannot be 9. So on our number line, if we were to graph it, at 9 we would have an open circle. It could be everything negative from that number. It could be everything positive from that number. It just cannot be 9. So this is supposed to be an or statement. I can really look at my greater than symbol and remember what I taught you, and I should know this is supposed to be or. So if I'm reading from left to right, it can be from -infinity up until 9 with a parenthesis because 9 cannot be included, or it can start again from 9 not being included and go all the way to positive infinity. So this is how the answer should have been typed. Okay, our next question, I need to get rid of the -4 out front. So I'm going to divide both sides by -4 because it's being multiplied. When I divide or multiply both sides by a negative number, this sign flips. So what I'm really looking at is the absolute value of 3x minus 1 is less than or equal to 8 divided by -4 is -2. Now I can make a judgment because the absolute value expression is alone. So it says less than or equal to -2. Well, definitely can't be equal to -2. Can't be less than -2 because that's going to be still a negative number. So this is going to be no solution. Our next one, I need to add 3 to both sides. That's going to make it a 0 over here. Then I'm going to divide both sides by -5 to get rid of the -5 out front. 0 over negative 5 is still 0, but because I just divided by a negative, I need to flip. So I'm left with the absolute value of 2x plus 2 is less than or equal to 0. So I need to take a moment and decide what this is really saying. Less than or equal to 0. So less than 0, those are negative numbers. That's going to be a no. That can't happen. But we do know that it can be equal to 0. That's okay. So like the other one where there was only one number it couldn't be, this is going to be the opposite situation where there's only one number it can be, because the only number it can be is the number that makes it equal to 0. That would be the only number I can plug in here and make this a true statement. So we're going to figure out, by setting equal to 0, what's the one number that will make this thing result in a 0. So we're going to minus 2 from both sides. We have 2x equals negative 2. And when we divide by 2 on both sides, we get x is equal to negative 1. So that is the answer, but I just worked in an equality. I have to make sure that I know how to write this answer. If I were to put it on a number line, I would have at negative 1 a shaded in dot. It's not going anywhere because that's the only answer. So if negative 1 is my answer and it's included, it will be in square braces. This is the way that it should have been written in interval notation. Our next one, I have got to understand that this negative 10 and this 1/2 cannot be put together because this 1/2 is being multiplied by this absolute value, and this negative 10 is not. If there's a plus sign in between them, this is stuck. All I can do is add 10 to both sides first. It's going to give me a 0 on the right side. To get rid of the 1/2, I'll multiply by 2 to cancel it out. And then I'll multiply by 2 on the other side, but 0 times 2 is still 0. So we're left with x minus 4 in absolute value is greater than or equal to 0. Well, absolutely everything that I plug in here will be greater than or equal to 0. So therefore, this is going to be infinite solutions. If it had just been greater than 0, then we would have had to find out what was the number that would make it equal to, and that would not be part of the answer. All right, so getting to the last two questions. Number 21 said the length of the rectangle is 15 inches longer than its width. The perimeter of the rectangle has to be between 50 and 70 inches. What are the possible lengths for the width of the rectangle? Select all that apply. Well, I'm going to do it as if I didn't have multiple choice here so that I know how to do it in the future if it is an open-ended question. So I'm thinking that I have a rectangle, and you just have to, not judge me because this is kind of hard to draw on. And if I label it with what they're telling me, that my length is 15 inches longer than the width, and I know that rectangles have sides that are equal but opposite. I don't know what the width is, so I'm just going to label those as W. And I know that I find a perimeter by adding all four sides. Well, if I collect like terms, I have 1, 2, 3, 4 W's. And 15 plus 15 is 30. And that has to be between. It doesn't say between or equal to or between those numbers inclusive. So just between is going to be without the equal to sign. And it has to be between 50 and 70 inches. So now I have a compound inequality in the form of an and inequality. So I'm going to solve this. I'm going to solve the middle out from both sides until I have a W left alone in the middle. So I'm going to minus 30 from all sides. And I'd be left with 20 is less than 4W, which is less than 40. Then I'm still trying to get W alone in the middle, so I'm going to divide everything by 4. And what I'm left with is 5 is less than W, which is less than 10. So W, the width, can be between 5 and 10 inches. It can't be 5, it can't be 10, but it can be absolutely anything in between those two numbers. So the only numbers that fall between 5 and 10 that don't include it are 7 and 8. Okay, the ideal radius of a piece of plastic pipe is 3.50 centimeters with an allowable error of at most 0.25 centimeters. Which pipe will you pick? So what they're really saying is that this pipe could be 25 um, less than 3.50, or it could be 25 greater than 3.50. So the absolute difference between x and 3.50 is at most 0.25 centimeters. So if I was working this as an absolute value equation, I would know that it has to be 25 to the right or 25 to the left of it. So I'm thinking 3.50 minus 0.25 and 3.50 plus 0.25. So that gives me 3.25 and 3.75. So this is what I get for my two answers, and it says allowable error of at most, so I know that it can actually be greater than or equal to. So this is not an equation, it's an inequality because it says at most. So it can be all the way up to that and include that. So 3.25 is an answer, 3.75 is an answer, and anything that falls between there, which we have 3.65 falls between there, so that is also an answer. So that should have been all of the questions on the 2.8 practice. There you go. Let me know if you still have questions afterwards.